Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. Without further delay, we invite you to sit back and enjoy the demonstration.
Now, to program a finishing operation on this model, we could, since we are using a turntable on the robot, we could use a 4-axis operation, like a 4-axis finishing operation, to program it. And let's go over and take a look at how we could program a 4-axis toolpath in here. So I'm going to go back and switch over to RhinoCAM. And here I have a 4-axis operation pre-programmed. It's called 4-axis parallel finishing, and you can find these under the 4-axis methods. There are a variety of different 4-axis methods you could program. We have drive surface machining, 4-axis engraving, parallel finishing, R-level finishing, and also facing pocketing profiling. Now for this particular model, I've programmed a 4-axis parallel finishing toolpath, and let's go ahead and run a verification of it in here. So I'm going to select it and then go to play, and you'll see that the tool remains normal to the rotational axis. So as you're programming it, the table, you can have the rotary table turn back and rotate back and forth to be able to reach out to all the areas on the model here. So this is a 4-axis parallel finishing toolpath, and you can see the simulation of the 4-axis toolpath in action in RhinoCAM. And if you'd like to speed up the simulation, you can use these controls in here to speed it up, to have it go faster or slower in RhinoCAM. So once you have these 4-axis toolpaths programmed in RhinoCAM, you would go ahead and post-process these out to app CLS from RhinoCAM, and then we will transfer the app output from RhinoCAM to IRBCAM and configure the configure the station and configure the targets. So at this point, I'm going to hit pause to pause the simulation, and I'll post-process this output into IRBCAM. So I'm going to post it, and there's the posted output file, and I'll switch back into IRBCAM's interface, and I'll go up to the file menu. Now since I already have defined the station and the part geometry is all defined, all I got to do is go back to app and choose load apt. And I'll go ahead and select the finishing operation we just posted, select open, and specify the minimum distance between the robot points. Click OK to accept it. Now if you wanted to append the finishing operation to the roughing operation, you could have chosen append in the options dialog that just popped up. So we have all of the points, the motions loaded in here. In this step, we want to go ahead and configure our targets. So we'll go over to tools, and then we'll select configure path. Now right in here, I could specify the different options for configuration. So for the initial orientation, I'm going to set my tool roll angle to 90 degrees. And I'm going to set it, the wrist to be wrist down. As you can see, it changes the wrist position. And rather than using a fixed angle, I'm going to pick a dynamic angle which would allow the turntable to be, the rotary axis to be rotated in here. And I'm going to go ahead and accept that. So now the path is being configured in IRBCAM. Once the path is configured, we can now run a verification. So all the targets have been configured, and let's run an animation in here. So you'll now notice that the part is being rotated on the rotary axis. So you could use 4-axis toolpath methods with the turntable to program your robot for machining for applications like these, which require machining from multiple different orientations. At any point of time, you can hit pause. You can also skip through some of these target positions in here, and then click OK to continue and animate it. You could also use these controls to zoom in and zoom out as you're performing the animation.